Assalamualaikum and good morning. So today our group, which is group 1, will be presenting our materials for engineering application assignment entitled Structural Failure of the Highland Towers. This presentation will discuss the materials involved in the Highland Towers collapse, the fabrication and construction methods used, the causes of the structural failure, as well as several engineering improvements that could help prevent similar incidents in the future. First of all, let me introduce our group members. Me, I am Nur Fatima Ana binti Fauzi. Together with me are Alia Izani binti Jamaluddin, Balkis Damia binti Muhammad Zahari, Muhammad Haziq bin Basri and Nur Adibah binti Zakaria. Without further delay, let us begin our presentation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Adibah binti Zakaria and I am from group 1. We want to talk about structural failure on Highland Tower, which is one of the worst building collapse tragedies in Malaysia. So firstly, the incident occurred on 11 December 1993 at Ulu Klang, Selangor, where Block 1 of the Highland Tower condominium collapsed. The main causes of the collapse were landsliding, retaining wall failure, poor drainage system and continuous heavy rainfall. The condominium was built on a hillside area using the cut and fill construction method. During prolonged rainfall, water infiltrated into the soil, causing soil saturation and weakening the foundation stability. As a result, the retaining wall failed and triggered a landslide movement that caused the building to collapse. This tragedy resulted 48 deaths and became an important lesson in structural and material engineering. The incident highlighted the importance of structural reliability, proper material selection, slope stabilization, and safe hillside development to prevent similar disasters in future. Next, I will explain the types of material involved in Highland Tower. The first material is reinforced concrete, which was used for beams, columns, floor slabs, and retaining walls. Reinforced concrete was selected because it has high compressive strength and good durability. However, concrete is weak under tensile stress and can crack when exposed to excessive pressure and ground movement. The second material is steel reinforcement bar, also known as rebar. These steel bars were embedded inside the concrete structure to improve tensile strength and ductility. Steel reinforcement helps the structure resist bending and deformation, but it is vulnerable to corrosion when exposed to moisture and water infiltration. Another important material is the reinforced concrete retaining wall, which was constructed to stabilize the hillside and resist soil pressure. However, due to poor drainage water system and heavy rainfall, the retaining wall failed and triggered the landslide movement. And lastly, pipe foundation and soil materials also play a major role in the collapse of the building. Continuous rainfall caused the soil to become saturated and lost its stability, leading to foundation movement and structural failure of Block 1.
Assalamualaikum and a very good day to Madam Fauzia and my fellow classmates. Next, I will be presenting the part 3.0, which is physical properties of materials. My segment will focus on analyzing the inherent physical characteristic of the concrete, the steel foundation, and the hillside soil that ultimately contributed to the structural failure of the Highland Towers. Let's begin with the structural materials. The reinforced concrete utilized in the building had a very high density of 2,400 kg per cubic meter. This created an immense dead load. Once the soil began to displace, This excessive weight exerted a critical vertical stress on the foundation. Embedded within the concrete was the steel reinforcement, which has a density of 7,850 kg per cubic meter. The major physical flaw here was its high susceptibility to corrosion or oxidation. When exposed to moisture, the steel rust and expanded in volume. This rust expansion caused concrete spalling, cracking the concrete from the inside and destroying the mechanical bond between the two materials. Moving on to the most critical natural factor, which is the saturated clay gravel soil. The primary failure mechanism here was caused by a physical phase change. Following 10 days of continuous heavy rain, the soil exceeded its physical saturation limit. Because of its high clay content, the soil transitioned from a stable, compact solid state into a highly plastic, viscous mass. The physical phase shift drastically eliminated the soil shear strength, triggering the massive mud flow that destroyed the foundation. To summarize the physical properties that led to the collapse, first, concrete. Its high density and porosity led to a massive dead load and internal water degradation. Second, steel. Its corrosion susceptibility caused rust expansion, leading to bone loss and foundation buckling. Lastly, the clay soil, exceeding its saturation limit, caused a fatal phase shift into a plastic mess. That concludes the physical properties analysis. Thank you.
Hi, my name is Balkis Damia binti Muhammad Zahari and I will be presenting about mechanical properties and microstructure. First, reinforced concrete was widely used in the building structure, retaining wall and foundation system. Concrete has high compressive strength but low tensile strength, making it vulnerable to cracking under excessive lateral pressure and ground movement. During the incident, continuous heavy rainfall increased soil saturation and generated excessive lateral loads on the retaining wall, causing structural instability and eventually landslides. The microstructure of reinforced concrete consists of cement, paste, aggregates, pores, and microcracks. Water infiltration through these pores weakened the internal bonding of the concrete and accelerated crack propagation. Poor compaction and inadequate curing during processing may also reduce the durability of the retaining wall system. Next, steel reinforcement bars were used to improve the tensile strength and ductility of the concrete structure. Steel has high tensile strength and good load-bearing capability. However, continuous exposure to moisture can cause corrosion on the steel surface, reducing the bonding strength between steel and concrete and weakening the structural performance. Lastly, soil and foundation materials also played a major role in the collapse. Continuous rainfall increased pore water pressure and reduced the shear strength and bearing capacity of the soil. Poorly compacted soil allowed rapid water infiltration, which weakened soil stability and accelerated landslide movement. In conclusion, the Highland Towers collapse occurred due to the combined failure of reinforced concrete, retaining wall systems, steel reinforcement, and unstable soil conditions under prolonged heavy rainfall. That's all from me. Thank you.
Okay, now we're focusing on fabrication method and structural failure. For this section, I will explain the fabrication methods and construction applications used in Highland Towers, as well as how these methods contributed to the structural failure. Highland Towers mainly use cast in situ reinforced concrete construction for the columns, beams, slabs, and retaining walls. Steel reinforcement bars were embedded inside the concrete to improve the structural strength and rigidity of the building. This method is commonly used in high-rise construction because reinforced concrete provides high compressive strength, durability, and economical construction cost. However, the main issue was not the concrete material itself, but the surrounding slope condition and construction planning. The retaining walls behind the building were constructed to stabilize the hillside and resist lateral soil pressure. At the same time, The project also used cut and fill construction methods to create a suitable platform on the hillside area. During prolonged heavy rainfall, water infiltration increased the soil saturation and weakened the slope stability. Poor drainage integration caused hydrostatic pressure to build up behind the retaining wall, which eventually triggered retrogressive landslide movement behind Block 1. This shows that improper slope management and inadequate drainage system can significantly affect the structural safety of hillside developments. So, for this slide, I will explain the foundation failure and several engineering improvements that could reduce the risk of similar incidents in the future. Pile foundation were used in Highland Towers to transfer building loads into deeper and more stable ground layers. This system was necessary because hillside structure requires stronger foundation support compared to the flat ground developments. However, the pile foundation became unstable due to the excessive horizontal forces generated by the landslide movement and weakened surrounding soil conditions. As the soil lost its shear strength due to the continuous rainfall and water infiltration, foundation displacement occurred and reduced the structural stability of the Block 1. Eventually, the building could no longer withstand the landslide forces and collapse. Several improvements could have reduced this risk. Firstly, a more efficient drainage system should be installed to prevent water accumulation and hydrostatic pressure behind the retaining wall. Besides that, stronger slope stabilization methods such as geosynthetic reinforcement and improved retaining wall system could enhance slope stability. Last, deeper and more stable pile foundation should be designed to resist both vertical and horizontal load conditions in hillside construction projects.
I will be presenting the key engineering solutions required for safe hillside construction, focusing on what went wrong and how can we prevent future failures from happening. To begin, the retaining wall behind Block 1 failed because it simply couldn't withstand the excessive soil pressure during the landslide. To prevent similar incidents, we must implement stronger retaining wall systems and slope stabilization methods. By using reinforced concrete retaining walls with proper reinforcement and deeper foundations, we can drastically improve the structural stability. Furthermore, we should utilize slope stabilization methods such as rock balls, geosynthetic reinforcement, and vegetation planting to strengthen the soil structure and reduce erosion. Together, these methods increase the slope's resistance against the heavy rainfall and soil movement. Secondly, proper soil investigation and foundation design are absolutely critical for hillside project. Before any construction begins, we must carry out detailed soil testing and slope analysis to accurately determine the soil condition, bearing capacity, and the overall slope stability. Engineers must ensure that the pile foundation system is specifically designed to resist both vertical and horizontal loads caused by landslides or soil movement. Implementing deeper and stronger pile foundations will significantly improve the stability of weak hillside soil. Additionally, strict monitoring and maintenance must be performed both during and after construction to guarantee the safety of the building over time. Our final key focus is improving the quality and durability of construction materials used in hillside buildings. The reinforced concrete and steel reinforcement bars used in the structure must have superior resistance against the moisture, corrosion, and cracking. For instance, using low permeability concrete reduces water absorption, preventing moisture from entering the structure. In addition, incorporating corrosion-resistant steel reinforcement or protective coatings will minimize rust formation caused by long-term exposure to water and humidity. In material science, proper material selection is very vital because the performance of these materials directly affects the reliability of the engineering structures. So by upgrading material quality, we ultimately improve the strength, durability, and also lifespan of the entire building. In conclusion, the Highland Towers clearly underscores the critical importance of proper engineering design, material selection, and slope management in hillside development. As we have seen, the collapse of Block 1 was primarily caused by landslides driven by heavy rainfall, poor drainage system, retaining wall failure,
unstable soil condition, and weak foundation stability. These all elements generated excessive forces that the structure simply couldn't withstand. Furthermore, moisture infiltration, corrosion, cracking, and soil saturation directly weaken the key material, such as the reinforced concrete and steel reinforcement bars, ultimately reducing the building structural ability. So to prevent similar incidents in the future from happening, we must implement robust engineering solutions, utilizing higher quality materials, stronger retaining wall system, advanced slope stabilization method, and proper foundation design will drastically improve the overall structural safety and durability. Ultimately, the Highland Towers case served as a powerful reminder of how vital material sciences and proper engineering practices are in minimizing structural failure, and most importantly, protecting human life.